what you know and what you wrote down, we're going to find the domain, points of discontinuity, et cetera, for all these different types of functions. Okay? For all these different types of functions. So let's look at this first one. You guys are going to have to write this in. We have x squared minus 4 all over x squared minus 7x plus 10. You're going to have a different function for every single one of these that we do. Okay? So, how do you find the domain of a rational function? What do? You put the denominator, and I need to figure out what x values are going to make that denominator 0. Now, this is a good old, and how do you solve a quadratic? What do I need to do? The x, I got to factor. Ask myself, what two numbers multiply to give me? Multiply to give me 10. Add to give me that. What are those two numbers? 5x minus 5 and x minus 2. I said both of those equal to 0, or in this case, not equal to, because I'm looking for the domain. This is me showing all the work. You necessarily don't have to do this. So what are my two values? So x cannot equal 5. X cannot equal 2. I can write that in set notation. Y'all remember the curly brackets? X is an element of what types of numbers? All real numbers. And that is the domain of this rational function. Questions? Points of discontinuity. Remember, there were 3 types of discontinuity. What were they? Infinite, jump, and hole. Slash removable. Okay? So, jumps only exist in piecewise functions. Okay? This is not a piecewise function. So you know it's either going to have to be infinite or it's going to have to be removable, a hole. Vertical asymptote or a hole. Okay? Now, when it says identify, it's pretty much like, okay, where are they located? That's what that means. And what type are they? So here's your example for your points of discontinuity. You have x plus 3 all over x squared plus 3x plus 2. Okay? Now remember, how do we find a vertical asymptote? If there is one, I need to set the denominator equal to 0. Well, if I do that, that's again, this is nothing but a good old, so I need to factor. What two numbers multiply to give me 2, add together to give me 3, positive 2, positive 1. Now, real quick, since that is what the denominator factors down to be, and the numerator was x plus 3, does anything cancel out? So that means I have no, very good, no holes. If nothing cancels out, I have no holes. So I don't have any holes, but do I have vertical asymptotes? Yes, I have vertical asymptotes, and where do they occur? Where? And how do I write them? Remember from the other slide.
Oh.
Remember I had circled it. It was like right here in this general area.
X equals.
Thank you. X equals -2, and x equals -1. Remember, it's always x equals for vertical asymptotes. Questions? So when it says identify, you're either looking for a vertical asymptote or a hole. There are no jumps in these cases. Vertical asymptotes occur when the denominator is equal to 0. Holes occur if anything cancels out, but we didn't have anything canceled out here. Yes. Definitely want to identify what they are and then where they're located. A little bit more practice with the vertical asymptotes. You have x plus 6 over x squared minus 25. We just talked about it. How do you find your vertical asymptotes? Set the denominator equal to 0. So that's x squared minus 25 equal to 0. How do I solve this? And you got to remember, when you square root, thank you. So x equals a positive 5 and x equals a, and those are your vertical asymptotes. Will you always have 2? No. Sometimes you'll have 1. It depends on what the denominator is. Sometimes you won't have any vertical asymptotes at all. Okay? You cannot have a vertical asymptote where you should have a hole. Okay? And we're going to talk about that next with this next example. So, any questions up to here? How do I find a hole? Cancel out any factors that are in common. So we have x plus 6 all over x squared plus 3x minus 18. I need to factor the bottom. How does the bottom factor? Do they have anything in common? The x plus 6. This is what I meant. X plus 6 is the factor that's going to give me a hole. I cannot have a vertical asymptote where x plus 6 is equal to 0. It's either or, it's not both. Okay? So when you're given a situation where it's asking you to find a whole bunch of information, like I give you a function, I'm asking you to find everything about it, you identify which one is the whole before you do the vertical asymptote. Did everybody hear me?
The vertical asymptote would be x equals 3.
So in this case, the only vertical asymptote would be x equals 3. Because at x equals negative 6, there's a hole. So we know that the x coordinate is negative 6 because remember we set that factor equal to 0 and we solve it. So how do I find my y coordinate? And what is left from this? It is 1 over. It's always one over. We canceled that out, but there's still a 1 there. When I plug in negative 6 into what remains, that's going to give me 1 over negative 9 or negative 1/9. And yes, that's my hole. Very good. Let's talk about the horizontal asymptote. Okay? Horizontal asymptote. What do I look at for that? The degree. So I have x plus 1 over x squared minus x minus 12. If I look at the exponent, the degree, what's the degree of the numerator?
1.
What's the degree of the denominator?
2. So y is 0 and the denominator is 0.
Very good. Y is equal to 0 because the numerator is smaller than the denominator. That's it. Y is equal to 0. Very good. Now real quick, teachable moment. If it was the other way, if it was the other way around, let's say it was x squared minus x minus 12 all over x plus 1. This would be no horizontal asymptote. It would be oblique or slant. It would be a slant asymptote. To find those, you do synthetic division because it's an equation. Okay? So this one would be no horizontal asymptote. It would be slant, and we would need to use synthetic division to find the equation. Sometimes you will be asked to actually figure out what is that slant asymptote. In that case, it would be a line that you have to graph. Okay? y-intercept. Let's find the y-intercept of a function, one of the rational functions. How about this one? How do I find the y-intercept of this? So I plug 0 in for x. When I do that, I have 0 plus 6 over 0 plus 2. 6 over 2, which is 3. So then we'll have a point. Zero, 3. Very good. We all right? Lots of information. Lots of information. Okay? Let's find an x-intercept. X squared minus 7x minus 18 over x plus 3. How do I find the x-intercept? And technically this is y equals, right? So when I said this equal to 0, how do I solve this? What do I do? When I multiply both sides by x plus 3, what happens on the left side? It stays to 0, and on the right side, this cancels, right? So I'm left with the numerator. Now, if I set every rational function equal to 0, isn't that always going to happen? It will. So you can even say in a rational function specifically, you just set the what equal to 0? The numerator. And then you solve from here. This factors to what? So that means my x-intercepts are going to be where? And you want to make sure you write them as a coordinate. No, it's an intercept. 9, 0. And negative 2 0. That's my ampersand. That's a little and. That's what that is. Make sure you write as a point because you don't want me to think that you're talking about a vertical asymptote, right?
Right.
Uh-huh.
Can't have that.
Can't have that. Okay? There we go. Last one. Woo! Trying to give you a different example so you guys can get that practice instead of just doing that one problem and doing everything with. Even though that is what you're going to be doing. I'm going to give you one problem to find everything. Okay? Give you some different problems. Last one, find the range. We're going to do x squared plus 6x plus 8 all over x minus 3. When, all right, when we do the range, what affects our range? The horizontal asymptote. So we need to find the horizontal asymptote of this.
Okay.
To find the horizontal asymptote, we look at the what? What's the degree of the numerator? What's the degree of the denominator? There is no horizontal asymptote. There's a slant one. But the thing is, slant asymptotes don't affect your range, only horizontal ones do. So if there is no horizontal asymptote and there is no hole here, right? There's not going to be a hole here. Nothing cancels. That's going to be x plus 4, x plus 2. That means our range, what do you think our range is going to be? All real numbers. Negative infinity to infinity. If there's no horizontal asymptote, and there's no other points of discontinuity, like a hole, I mean, then your range is negative infinity to infinity. It's a lot of information. That's why I wanted you guys to be able to write it down yourself because you have to think, okay, what did I say was the domain? You see what I'm saying? Not what did Ms. Anderson say. Hopefully you remember more what you said versus what I said. All right, I want you to try this one. I want to give you a rational function,
Gotcha.
and I want you to find all the information, okay? Here it is. Y equals x squared plus 10x plus 25 all over x squared minus 25. I want you to find all the information: domain, horizontal asymptotes, points of discontinuity, vertical asymptotes, holes, y intercepts, x intercepts, and the range. All right, so let's take a look at this. We're finding all this information. Now, this is more like what you're going to be doing here. I'm going to give you a function, a rational function. You have to find all this information about it, okay? At least for your homework tonight, that's what it's going to be. Giving you 4 functions, and you have to basically tell me all this information about those 4 functions, okay? So, we have to figure out the domain of this function. The domain is everywhere, what? What in your words, how do you find domain? The denominator cannot equal 0. So that means that x squared minus 25 cannot equal 0. So when we solve that, what did you get? 5 and negative 5?
Yeah.
Did you write it in set notation or interval? So it's a set of x values such that x 5. So plus or minus 5?
Yeah.
So, and x is the element of all real numbers, correct? Here we go. If you wrote them separately, that's fine. I don't have that much space up here, though.
If we wrote it like that, like on the test, would it be wrong or would it be fine?
No, it'll still be right. Yeah. Okay. Now we have to identify any points of discontinuity. Did we have a hole?
Yes.
Did we have a vertical asymptote?
Yes.
Yes. So you have 2 different types of discontinuity. Remember, you can only have a hole where a term does what? Or a factor does what? Cancels out. In order for it to cancel, I probably need to do what to this rational function? Factor. My suggestion, once you find the domain, factor, 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 once you find the domain, okay? Sometimes you might even need a factor for the domain because it might be like a trinomial, but factoring should be like one of your first 2 steps. How do I factor the top? X plus 5, x plus 5. How's the bottom factor? What do you see when you factor the top and the bottom? They both have the x plus 5, which means that cancels, and that means there is a hole. So we have a hole, and where does that hole occur? We set it equal. We get x is equal to negative 5. How do I find the y coordinate of that hole? And what's left over is this. This is what's left over. So when I plug negative 5 back in, that's negative 5 plus 5 over negative 5 minus 5, which is 0 over negative 10. What's 0 divided by negative 10? So I have a hole at negative 5, 0. I have a hole at negative 5, 0. But I don't just have a hole, I have something else too, don't I? A vertical asymptote. Where does my vertical asymptote occur? Be specific. X equals 5. It's where that other denominator, that x minus 5, is equal to 0. So I have a vertical asymptote at x equals 5, and I only have one. I cannot have a hole and a vertical asymptote at the same location. It's one or the other, and it's the hole. The hole is always going to trump the vertical asymptote. Question on the left side. Right side. Now, once you found you found the simplified form, you can always use the simplified form to answer your questions. You don't have to go back to the original. Okay? You can always use the simplified form to answer every other question that you have from here. Okay? What was the horizontal asymptote? Y equals 1. Because not only from the original red equation were these 2 exponents the same, those leading coefficients, when you look here, the degrees are the same as well, and it's still the leading coefficient. So whether you use the original or the reduced form, you're still going to get the same horizontal asymptote. And it is y equals 1 because it's equal. It's the coefficients. So whatever the coefficients are, which were 1 and 1, you divide them, that's what you get. To find my y-intercept, I'm not going to lie. Plugging it into this blue reduced form is a lot easier than probably plugging it in up here. I'll still get the same answer though. This was just a little bit easier. Okay? So, when I plug in what? 0, 4, x, what number do I get? -1. So it's written as a point. 0, -1. Very good. How do I find my x-intercept? Plug in 0 for y or, a little louder, set the numerator equal to 0. Since I already have this reduced form, I can always go back to the original, but there's an issue. Remember, one of them is a whole. So I got to be careful about that. Okay? And this one just so happens that it actually, the x-intercept is where the hole occurs. Okay? It crosses at the x-intercept. That's where the hole is on the x-intercept. But it's fine. I just know that when I graph it, I don't actually put a point there. I leave it as an open circle. Last but not least, what's the range? Y cannot be 1 because that was the horizontal asymptote. Y has to be all real numbers. Again, the range is whatever the horizontal, everything but the horizontal asymptote. What about the whole? Ooh, you got me. You're right. Good catch. Not only is it at 1, but it's also at 0. That's terribly written. It ain't pretty. So to write that, does everybody have this? So to write y does not equal 1 and y does not equal 0 in interval, it would basically be from -infinity to 0, 0 to 1, 1 to infinity. There's nothing wrong with that. I'm going to write the one. Okay? So that's how you apply all the properties.